Alright, time for another draftphysics.com, debatephysics.com also, but the debate is pointless because science, quote unquote, the people interested in it are lying morons, okay, and that's the conspiracy. So, like religion, where it's just morons, they have doubled down and they do lying and moron. So, it's worse than a religion because of the lying part, right? they can't they can't make an honest statement. They can't make an honest argument. Can't debate honestly. I mean, and the Paul Nord 2-month exchange proves it. Every single point I made, he evaded and just ignored. Every single one. Not a single counter argument to a single one of the specific arguments made. All right, so all of this is about, it started, 4 years, no point in going through it all, physics girl video. Anyway, so they're contending, so Steve Mould makes this moronic video where he basically says the law of the lever doesn't work. So this proven science where I can put a 4 mass on one side of the lever, 4 mass, same distance, it will rotate on a disc, okay, at a certain speed. It'll take a certain energy to move it. Same argument. I could put the 4 and the 2, and that will be the same. That will oscillate perfectly, okay. It obeys the law of the lever. So the 2 mass will go twice the velocity, equaling the 4 mass going 1 velocity. And then I can do the more extreme of having the 4 mass on one side close, and at 4 distances away I can put a 1 mass, and those momentums are the same. The energy required to create that motion is exactly the same. Now their argument is this is true, this Leibnizian notion that you simply take a 1 mass going 2v, twice the velocity. I put a 1 mass here, and somehow it's going to equal. So a 1 mass going 2 equals a 4 mass going 1. Now, obviously, the momentums aren't the same, so to make your argument that somehow I can use the same force and I'll make both of those events happen is idiotic. I mean, that's the absolute moron part. Now, the lying part is for them to imply I've ever said anything else, that I've never made any such argument other than you just have to balance the MVs. I mean, I've written it hundreds of times. What levers convert is from a big M and a small v into a big V and a small m, and that's what they do. This total number has to equal this total number, or it's not balanced. That's the explicit argument, and they're making an explicit counter argument that this isn't true, that I can have different momentums that will be the same amount of work. So I have to do a 1.4 mass to a 1 mass. These kind of bizarre ratios they say will exist. And again, they're completely lie about everything that's taken place. So I just made a video pointing out how his last video was an entire straw man, had nothing to do with any argument I made. I clearly state if you obligate it to make more momentum, if you make the whole thing bigger, okay, that's not going to equal, okay? If you don't proportionally reduce a velocity as you reduce a mass, increase a velocity as you reduce the mass, well, that doesn't work. So this won't be, okay, this smaller v and m, that won't equal because those momentums aren't the same. So there's no confusion about my argument. And they just lie, create this straw man that somehow I said something other than what I've said, that the momentums have to be exactly the same for it to spin the same. And it will in fact spin the same. A 4 mass here and a 1 mass here will spin the same as a 4 mass here as a 4 mass here. And it's as simple as just understanding that, well, let's say this was just a place and I put 100 pounds on this side and 100 pounds on that side. I would have a certain amount of difficulty spinning it. And if I doubled the mass and left them in exactly the same place, obviously it's going to take twice the work to spin it. Obviously. And I never made any such argument otherwise. And so it's all so fucking dishonest. So they're breaking a 2,000-year-old law of the lever, claiming it's erroneous, that their new modern physics has figured out some new magical theory okay, and somehow, okay, these proportionalities of momentum are meaningless, and somehow the magical kinetic energy will work. Now, obviously, it won't work if I put it on a lever and a balance, okay. One mass going 2v will not balance the 4 mass going 1v. It won't happen. It won't even be a close contest. Complete loss of any notion of balance. And yet here they are making this argument. And then people ask me, well, what do you believe in conspiracies? So it's not conspiracy that creates UFO nuts. It's not conspiracy that creates flat earthers. It's asshole. That's what creates it. And that's sort of my argument, is apparently there's very few people on this fucking planet who aren't a fucking asshole, an idiot, a moron, spouting crap way above their grade level. They can't, they can't hit the bar, the 3-foot high bar. They can't jump the matchbooks boxes, to use another Monty Python reference. They can't handle anything close to the truth. Oh, fuck. So just so irritating to have to argue lies. I mean, it'd be nice if they could make a physics argument instead of just lie. Alright, so we'll play some clips out of this video. I don't think we're going to bother playing the whole stupid video. It's 10 minutes of gibberish mostly. So here's a key point where he makes a key argument, and clearly let's just understand it has nothing to do with anything I have argued. It doesn't in any way contradict anything I have argued. I have never stated you could take 4 pounds on one side of a wheel and 4 pounds on another side, and then you could move them twice the distance on the wheel, and now the wheel is just as easy to move. The weights will move the same velocity with the same force put in, but obviously how many times the wheel rotates with the weights out here will be vastly different. And if I put the weights out here, it's even now more weight, okay? It's 3 times the distance, so it's only 3 times the weight, so it's 3 times the amount of energy you'll need to make the whole wheel spin the same speed. But if you use the same energy, you're just going to have the same speed of these objects. Obviously, speed over this huge distance means the rotational, right? So if I go 40 miles an hour here, it only takes me a tiny second to get there. If I go 40 miles an hour out here, obviously it takes me a long time to get there. So the objects have the same momentum. They're the same masses moving the same velocities, but the wheel itself, the lever, is moving much slower. And that's obviously what was shown in this video. And it doesn't contradict anything I have argued ever. So he's just such a liar to imply I ever suggested something different would happen.
Velocity, if you like, they'd be the same.
The linear velocity is the same. The angular momentum is the same, because you have increased the distance traveling in this same time. So in the same time, when it's in close, the wheel moves a lot, and when it's further out, the wheel moves a lot less. The wheel. The weight moves the same speed, but the wheel itself moves slower.
So that's conservative, isn't it? Really? Because it's the same energy going in, as you say, Gary. So
that's exactly what I said. The same force is causing the motion. You have the same force, you can only have the same momentum, and so you're just proving my point and somehow arguing that you're proving me wrong when you're proving me absolutely right. And so go ahead and put the one mass at 2 distances and show how that's the same as the 4 mass at 1 distance. Go ahead and show that.
if the velocities are the same, but when the weight's out here, it's travelling twice as far per oscillation as it is here per oscillation. So you think, oh, that's not conservative. It's doing twice the distance. But because the oscillations per second are only half when it's out there.
Okay, so this is just obvious. The point is, I never argued that you can change the momentum and with the same force, that you can use the same force and create two different amounts of momentum. I'm the one arguing that force is momentum. You can never do that, so they're equal. So the force in is going to be the force out in terms of the momentum total out. So you're just proving exactly what I've argued and pretending that somehow this is one of your I got you moments, when no, you caught yourself, moron. I mean, the hook is in your own ass. Alright, I'll play it and see if he says anything relevant. Can't happen. I mean, the comments just indicate he doesn't say anything meaningful in this video, except they're doubling down on this moronic argument that somehow the law of the lever doesn't apply, when it'll always apply if you do it right. Alright, so now he just said the magical work is force times distance, and he says it all works out the same. It only works out for momentum. So if you calculate the kinetic energy of where you've put your objects, okay, in terms of your understanding of the mechanism, it wouldn't be the same. But in this case, he's not changing the masses, so it won't. The kinetic energy will be the same because, as pointed out, the masses are moving the same velocity. But go ahead and try the one mass going 2v, okay, equaling the 4 mass going 1v. Go ahead and show us that. Liar. Alright, so he's just said the words, I'll show you a free energy machine, and he titled the video A Possible Free Energy Machine. So we'll play this, because this ought to be absolute nonsense, and it won't be a counter argument to anything I have said. It's just more lie science. These people are more despicable than flat earthers. Their dishonesty is just so glaring.
Just like that. Forget these weights where they're not here. This is for you, Gary, as well, or anybody.
Yeah, go fuck yourself till really good and dead.
Because we can make a free energy machine, I think. It's just a...
You can make a free energy machine just by doing what I stated is your challenge. You're the one saying that a 1 mass going 2v has the same energy as a 4 mass going 1v. Well, why don't you just show me? Show me them doing the same work on your lever.
The lever here, no weights on it. We've got 2 weights. 2 weights there. Here, there. I don't start that. Now, the further out you put a weight, the more force on the lever, isn't there? The more force there is.
Now, the calculation of the force that's in gravity, but if I put it on a lever horizontally, there's no more force. But if I want to push it, now it's a lot more force. So I can't give it, I can't use the same energy to move it the same distance, a rotational distance.
Here's a little bit of force. If you had a force scale, there's a little bit of force. The further out, more the force is here. You know that, don't we? The further out we go with the weight, it's the same weight, but more force on the fulcrum, or more force this end.
So there's no more force on the fulcrum. The fulcrum couldn't give a shit about, what you're pretending that you're creating some sort of force on the fulcrum. The fulcrum is basically just reflecting. It's not absorbing anything. So there's no more force. The gravity is only creating a certain amount of pressure. Again, you still don't understand how levers work. They're putting tension on each other from their relative positions, but there's no more force. It's the same amount of force. It's either a smaller amount of distance or it's a bigger distance. I mean, you're supposed to think that the distance matters, and then you're making it like it doesn't exist, and that's all you're changed. You're just changing how much distance you have to move the object.
Okay. The balance sheet, we're going to move this one out, right, you see. And so you would think, and I think, well, more force, both pushing down.
So there's no point, right? Just put a scale on, just put your whole mechanism on top of a scale, and it's not going to weigh more when the two things are on the outside. So the fulcrum's obviously not feeling any more mass. It doesn't recognize the existence of any more mass. The scale's not going to read 16 pounds because you put the 4-pound weights 4 units of distance out, or 32 pounds, doubling the 16. That's not going to happen, moron.
Both pushing vertically down. There's got to be more force on the fulcrum.
So you're saying so, but again, you don't know anything about physics. So, and again, you could just sort of understand that you can't change how much weight is on the fulcrum because you didn't change the masses.
Is that what you were thinking, Gary, as well?
No, yeah, I'm thinking you can't change. You can't put the whole experiment on a scale and make it weigh something different by moving the masses around. You can't do it. Can't happen.
You know, you're like me. I was thinking that. So the further out we put the weights, the more force there is on the fulcrum, right? We've got to be in there. You know, intuitively, the further out is more force pushing this end of the lever up. So to balance it, we push it.
So again, it's not doing it. The weights aren't what pushes the lever up and pushes the lever down. It's just the lever itself. The little fulcrum is changing how much mass is on one side of the fulcrum of the middle, and that's it. There's no other force involved because the other two forces cancel each other. It takes the same work to move this as it takes to move this. So it's irrelevant. The masses become irrelevant.
This one on, out here, they're both pushing in a vertical down direction. More force on the pivot. Now, where's the free energy machine?
Yeah, well, you're promising a free energy machine, so yeah, where is it?
This lever is on a sort of a crane system, if you like. It can move from ground level as it is here, or and right up in the sky.
All right, so again, totally irrelevant. So again, there's no difference. The rate of gravity is the same way up in the sky as it is way down in sea level. It's still 9.8 meters per second, and the only thing you're changing is the 400th decimal point, and so it's irrelevant how high above sea level the lever is.
At ground level, we start off with the weights together like this, and they're putting the minimum amount of force on the fulcrum downward.
So this is just a waste of time, apparently. Okay.
And we lift the crane up, we power it up to 100 feet, turn the motor off.
Yeah, well, leave the two things in close and then lift it with the two things really close and then put them on the outside, and now somehow they'll magically weigh more. Yeah. Is that your theory? Oh, fuck. So again, he just did a straw man video, now he's doing another straw man video. Right? I mean, where did I ever argue that somehow there's more force on the fulcrum or the lever weighs more when the objects are on the outside? I didn't say any such thing. The object weighs more relative to the other object, okay? I mean, it's just, I said relative to the fulcrum, okay? From the center of mass, it weighs more. It doesn't have more mass, it just weighs more.
Before we let it drop, we roll the weights out. So they're right out here. It doesn't take much energy because it's on a level. You know, there's no little friction.
Okay, so again, what is this? This doesn't have anything to do with me. Okay, I drew things like that when I was 17, 18 years old. Because until you prove it to yourself, perpetual motion is impossible. There's you're kind of thinking, well, gravity's a stream. I mean, why can't I just stick something in the stream and collect the energy? It's got to be a way of going upstream, like walking upstream, throwing something in, letting it go down, and then just walking upstream, throw it in. There's got to be a way of tricking the system, but there isn't.
Doesn't take much energy. Roll them out there. Now they've got a lot more downward force.
So they don't have any more downward force. So again, I've never argued they have more downward force. So fuck you. You're a lying piece of scum.
We let the thing go and it descends.
I've made videos previously where I talked about putting the scale, put the whole lever on a scale, and that you can't change how much the experiment weighs by moving the masses. You can't change how much mass is on the scale.
More force than it took to raise it. There's a asymmetry there, isn't there?
No, that was a waste of time. Alright, well, I'll pause it here and see if he says anything else, but obviously this has nothing to do with my arguments, and has nothing to do with proving their argument. They're claiming a one mass moving two velocity is the same work to create as a four mass moving one velocity. So I have a four mass on the inside of the wheel on one side, and just a one mass moving two velocity on the other side. And they say those two things are the same energy to move. and it's clearly nonsense.
I was curious about that, and because I am curious in any way, I want to know the answer.
Oh, I'm supposed to pause this. It's just a waste of time. Okay. Fuck. Alright, so now he's gotten to something relevant. So instead of moving the full mass over, he's taken a balance, okay? So let's say we had a 4 here and a 4 here, and he's now cut it in half and put it twice the distance. So that should equal the 4. It should rotate at the same speed. It should match the metrodome. All that should happen if he has the distance right. And the simple argument is he doesn't. And so he doesn't have a lever there. He can slide the weights into different positions, which he should be doing. I mean, if you're going to bother doing these experiments, you should have great liberty in where you put the balance, put the weight. And the weights are also not freely dangling, which is also, hurts the experiment, because when they're moving this way and this way, you're changing their center of mass. You're making the lever essentially longer and shorter, and so that's a no-no.
The camera angle to get the oscillator in.
So this will probably not oscillate at the same speed because he doesn't have the distance quite right, and all he has to do is move it a centimeter and it will oscillate at the same speed.
Do this. If anybody's interested in the result of the force on the fulcrum with the weight. So now we've got half the mass, twice the distance. We've done all this thousands of times, haven't we? I mean,
Okay, the thousands of time bullshit again, alright? Yeah, you've done it wrong thousands of times. So the simple argument is you're not accounting for the mass of the lever. It has to be part of the equation of where a half mass is, or, the whole idea of what is equal. And I'm just saying that, technically all you have to do is be able to move that mass. But the fact that you have a rigid mass on there means you're changing the length of the lever. So of course that's not going to oscillate at the same speed. But how far is it off? Are you going to measure it and count again? So give us the count. You gave us the count for the other thing. Give us the count. How far off is it?
I had 2 of these levers set up with 2 fulcrums to show them side by side. Going back a year, 2 years. How they would differ,
Yeah, garbage. Just junk videos. I mean, it's just amazing, okay, that you're going to keep defending the garbage you have posted in the past. Amazing.
I'm guessing that's about half the frequency now.
You're guessing, so you won't bother doing the count for us, and then you won't bother moving that mass, 3/4 of an inch and see if it makes all the difference in the world.
Anyway, and this business, Gary, about if it doesn't do what you say, then we know the weight's in the wrong place. And
there you go. That's it. Yes, that's the truth, fucker. So do it. Prove me right, okay, and show that, that's all it takes is a tiny adjustment and it's the same speed. Yes, it's the same momentum. Because I didn't really pay any attention to the fact that, yes, you have to calculate the whole mass of the entire object moving. And again, if you have rigid masses hanging down that are swinging in and out, they're going to change. Their weight is essentially changing every time the lever moves. They have a different weight. Moron.
You alter the weight, its position on the lever, to make it do the right thing. Well, then it wouldn't balance, would it?
Says you. Yeah.
That would be like cheating.
Yeah, did you try it? Yeah, no, you didn't. Alright, it'd be like cheating. So we never even saw it perfectly balanced. Let's see if we see it perfectly balanced here anywhere. So it's not balanced right now. Yeah, let's see if it's moving. Yeah, it's moving. Okay, we have to find a clip where it's not moving.
He's interested in the result of the force on the fulcrum.
Okay, so he says this one's perfectly balanced. You can see it has a bias up.
So now we've got half the mass, twice the distance.
So it's not perfectly balanced to start with. But regardless, I'm just saying the point is it's not an ideal lever. You don't want to pay attention to that simple rule and just demonstrate for me how much do you have to move the mass for it to oscillate at the same speed. And is it anything to do with your 1.4 theory? Okay. And clearly do what you're supposed to do. Put the 2 mass 2 units of distance and see if you can get it to equal the 4 mass at 1 unit of distance. See if you can make that happen. That Leibnizian notion of reality. Do that experiment. Lying scum. Anyway. Alright, so I did grab a couple of the images. So these are the starting positions for his experiment, right? And, you know, look, I mean, this isn't that complicated, but, you know, again, they don't pay any attention to, you can see how the images do line up. So if I line it up correctly, the hammer and all of the little lines match. His videos are inherently blurry, so I can't do much about that. But you'll see that, okay, so one lever's here, the other one is obviously being launched from a completely different height. So I've explained how the force going in is the weight difference you've created. By moving the lever up, you've shifted mass onto that side. That side is now heavier, and the amount of distance it travels will decide how much force it puts in. It's a gravity argument. So obviously if you make the arc higher and higher and it's going to travel more distance, it's going to have more force is going to be put into the experiment. So you could just understand that, yes, I'm essentially pushing the wheel harder. So I'm spinning it with more energy. So obviously they can't rotate at the same speed because you put more energy into one of the experiments that was in the other experiment. That's probably why his results were, you know, when he counted the rotations, was 98 and 58 or something. The reason why it wasn't half the amount is because he's not doing anything to make sure he's moved the lever to exactly this, he's released it from the same point. So it's not even close. Like I said, this is a huge 15-degree difference. I mean, it's a gigantic difference. So there should be no expectation that they would oscillate at the same speed because he didn't release them from the same point. They don't collect the same force from gravity. So obviously they can't have the same energy. That is, obviously they can't move with the same momentum if one of them has more energy in it. Duh. So, I mean, I'm sorry. I mean, it's not a clear video, but you can see the other one lever's way down here, the other lever's way up here. So clearly not the same energy. I mean, it's just such bullshit. Alright, this is kind of a nice drawing, so I might as well use it again. So essentially what he's done, alright, is, let's say you were using gravity to move this wheel. You know, you had a knot and you had a string going around the side of the wheel, and then you were going to drop a mass to give the wheel its rotation. Right? All he's done is, by dropping them from different heights, he's made it so there's more dropping distance. So the weight has further to drop. So you can understand that if it's able to drop further, it's going to give the wheel more energy. So obviously it's going to start oscillating at a much higher rate because of the increased velocity. And yes, Newton's pendulum law sort of is obedient, but the fact is it has its limitations. So obviously if you put more energy in, I have no expectation that if I allow the weight to drop a further distance, that the wheel's not going to move faster. Of course it's going to move faster. It's going to cover more radians, okay, per unit of time. The objects will have more momentum. So obviously in one case you gave the objects more momentum. So there's no expectation that the oscillation rate would be the same. Jesus. Too stupid. Alright, is there anything else to say on this subject? Let me pause and just make sure. I mean, look, I went over it. So their prediction is that the one mass going 2 velocity equals a 4 mass going 1 velocity. So even though those momentums won't balance on the lever, no chance, completely lopsided, they're saying it's the same energy to move those two things. So if I just put the 4 mass on here and spin the wheel, They're saying it'll be the same to spin this. They'll have to do the same work to spin the wheel with only having a 1 mass at 2 velocity. And you've got to know that can't be true. That's like saying I can put a 100-pound person here, and then I can put a 200-pound person here, and they'll spin exactly the same. Same force to move the wheel. You know it's got to be twice the force. And you know this can't be true. This Leibnizian moron notion cannot possibly be true. A 1 mass moving 2 velocity is not the same momentum. It's not the same energy. The wheel itself will not take the same energy to spin with the 1 mass at the 2 velocity position as the 4 mass at the 1 velocity position. If you make that wheel and then try to spin it, they won't require the same energy to spin the same speed. The 4 mass will require twice as much energy for the wheel to spin the same speed. All right. It's just so dishonest and so damn stupid. All right, since I'm here, might as well do this more subtle argument. So I have complained, okay, that the ideal is to have a weight that is free to move, so that when the lever's in some other position, the weight doesn't change its center of mass. And so what he's doing by using a rigid mass that's nailed to the board, essentially, okay, is that every time it swings out, you can understand it's doing this, right? It's moving its center of mass. So its center of mass starts being under the board, and then it swings out as the lever moves. So the more arc the lever covers, obviously the more the center of the mass is moving out this way, making the weight heavier to lift. So by having the masses attached, he's forcing the weight further out on the lever, essentially. So it's essentially the same thing as having it move out here on the lever as the lever is moving. And the further out he puts it, the more exaggerated that's going to be because of the arc that the lever travels. So, the circle issue. It's more up and down this way and more sideways here. So he's just, it's another imperfection, another variable not accounted for, that you want to always have the center of mass of the mass always in the same location relative to the fulcrum. And you're not going to do that if you put the mass in some sort of weird orientation. Oh, this is so bad. Anyway, so let's just say that's enough of a video and such and so forth and whatnot. Just tediously obnoxious. Just all so dishonest.